In this video, we're going to be looking at the multiplication rule of probability for event A and B. This is basically saying that the sample space is adjusted, and that's why we're going to be looking at the multiplication rule. So if A and B are any two dependent events in the following wholes, the probability of A and B is the probability of A times the probability of B given that A has occurred, which could also be written as the probability of B and A. This is just saying intersection is the probability of B times the probability of A given that B has occurred. And remember, and means multiply. The wording of all of this is kind of complicated. Conditional probability, the probability of an event occurring given that another event has already occurred, is what conditional probability is because there is a condition that the probability is set upon. The conditional probability of event B occurring given that A has occurred is called the probability of B given A. It's really loud here. My dog was just barking in the first take, so I'm just going to go with it. Sorry if it's a distracting video, but I'm going to do the best I can. All right, and then here's our notation for all of that. And I think the easiest way to do this is to look at a specific example. So in example 7, you are given a family with 2 children, and we want to find the probability of each event, assuming boys and girls are equally likely. So since there's 2 children, ignore the B and A right now, you could have 2 boys, a boy, girl, girl, boy, or 2 girls. And now we're going to look at find the probability that both are girls, given that at least one is a girl. Well, given that at least one is a girl, that limits you to these 3 possibilities, and they're both girls would be this GG. So we actually have 1 out of 3. So I know the answer. The answer is 1 out of 3. And that's the probability of 2 girls, given that 1 is a girl. And that's how this would write, and we know it's 1/3. If you look at it with the formula, the probability of A and B, so both are girls and at least 1 is a girl, we are looking at 1/4. Okay? If you are looking at just the probability at least 1 is a girl, then you are looking at 3 out of 4. Okay, and then if you divide that out, you multiply by the reciprocal, so 1/4 times 4/3 is 1/3, you get the same thing. Let's look at kind of the same thing with just a slightly different given that. So both are girls, given that the older child is a girl. All right, so I'm going to call this B and this C, and we're going to do the probability of B given C. So if the older child is a girl, now I'm looking at these 2 cases, just those 2, and both are girls is just 1 out of the 2 cases, so it's just 1/2. If you want to use the formula, probability that they are both girls and the older child is a girl is 1 out of 4. And then the probability that the older child is a girl is 2 out of 4, or 1/2. So you have 1/4 times 4/2. The 4's cancel, you get 1/2. So you're going to get 1/2 either way. So 2 events are independent if the occurrence of one of the events does not affect the probability of the occurrence of the other event. They are independent if the probability of B given A equals the probability of B, or if the probability of A given B equals the probability of A. Events that are not independent are dependent. In the real world, just to kind of go off the grid for a minute, independent events in the real world might look at like somebody speeding and someone having a good diet. Dependent events might be someone smoking and then having cancer, lung cancer. It could be somebody participating in cardiovascular workouts and then having a lower blood pressure. So the smoking can cause lung cancer. Having a strong cardiovascular workout will lower your blood pressure. So those are dependent of one another. So it's something that affects the other. We're going to look at this in a technical way just real quickly. A single card is to be drawn from a standard 52 card deck. Find each of the following given these events. So event A is the selected card is a face card. Remember, Jack, Queen, King are face cards. And then there are 26 black cards, so the spades and clubs. Okay, so the probability of B is going to be 1/2. Okay, half the deck is black. Probability of B given A would be the, to me, I would look at it this way. Even if you're looking at all of the face cards, you have the jack, queen, king, you have them of hearts, diamonds, spades, and then clubs. Not the best drawing, but you would have 6 out of the 12 changing the sample space, and that's going to be 1/2. And since they are equal, both equal 1/2, the events are independent. So I really want to do this with a two-way table because that's supposed to say clubs. Clubs. Yikes. Okay. Thanks to my neighbor for mowing and distracting me. Okay. The multiplication rule of probability for any two events is probability of A times probability of B given that A occurred. But if they are independent, it's just the product. It's just the probability of A times the probability of B. All right, so let's look at the situation. Each year, Chen adds to her book collection a number of new publications that she believes will be of lasting value and interest. She has categorized each of her 20 acquisitions for 2015 as hardcover or paperback and as fiction or nonfiction. The number of books in the various categories are shown below. So here's fiction, nonfiction, so the type. By genre, and then here's your physical type, hardcover or paperback. So for questions 12 through 14, if Chen randomly chooses one of these 20 books, find the probability that it will be each of the following: a hardcover book. All right, well, hardcover is just going to be the 8 out of the 20. Okay, and then the 8 out of the 20 will be, let's see, 8 out of 20. 0.4. I should have known that. All right, and then the next one we are looking at, find the probability that is fiction given that it is a hardcover book. So if we are looking at a hardcover book, I am now looking at this row. So given that it is a hardcover, so the sample space has changed. And if I want fiction out of the hardcover, it's just going to be 3 out of 8 or 0.375. And then finally, you want the probability that it is both hardcover and fiction. Hardcover and fiction is going to be 3, and this is out of all of them. So I'm looking at 3 out of 8, which is going to be 0.15. So in this case, it wasn't a given that, so you don't need to change the sample space. All right, thanks for watching.